Good morning, student. Where's the rest of the class?
Good morning, teacher. Ben and Jerry went to basketball. Mark and Spencer went to soccer. Tom, Dick and Harry went to rugby. And the rest of the class went to support water polo. So I'm all alone today.
Oh, okay, no problem. I will upload today's lesson onto Moodle so that the rest of the class can perform e-learning at home during e-learning's day. So today, we will be touching on the topic on work, energy and power. So how much do you know about work, energy and power?
Teacher, of course I know what's work, energy and power. When I have a lot of work to do, then I will use up a lot of energy and over time my power will be all gone.
This explanation is so creative. I think after today's lesson, you can impress your family and friends with the actual definition of work, energy and power in physics terms. Okay, so today's learning objectives are: at the end of the lesson, you will show an understanding of the concept of work in terms of the product of a force and displacement in the direction of the force. And you will also learn how to calculate the work done in a number of situations. And the next thing you are learning is that you are able to give examples of energy in different forms, its conversion and conservation, and apply the principle of energy conservation to simple examples. And finally, you will learn how to show an appreciation for the implications of energy losses in practical devices and use the concept of efficiency to solve problems.
Teacher, wow, I'm learning so many concepts in one day. I'm so excited.
Great! I'm so happy with your enthusiasm as well. So tell me, what is energy?
Teacher, I think energy is the ability to do work.
Oh, very good! So energy is definitely the ability or capacity to do work. So what do you know about the SI unit for energy?
I think it's joules.
That is absolutely right. So is it a scalar quantity?
It is a scalar, I think, because it doesn't have direction, but it has magnitude.
Very good. That is the answer. So can you give me some examples of different forms of energy?
Okay, kinetic energy, gravitational potential energy, electric potential energy, and elastic potential energy.
Oh, very good. So how do you learn so much?
I'm really reading from the lecture notes.
That is very wise of you. So the energies are as listed in the lecture notes. They are kinetic energy, and kinetic energy is the energy of a mass due to its motion. And gravitational potential energy is the energy associated with any mass in the gravitational field. And electrical potential energy is the energy associated with any charge in an electrical field. And finally, elastic potential energy is the energy associated with any compressed or stretched system. So some examples are springs, strings, or rods. Alright, so other forms of energy are radiation energy, thermal energy, internal energy, sound energy, and chemical energy. And you can actually read the examples as listed in the notes yourself.
Teacher, under thermal energy, why is heat energy often inappropriately used in its place?
Oh, this is because heat occurs in the process of energy transfer between two bodies due to their difference in temperature. After the transfer, energy resides in the body should be termed as thermal energy. So you should always use thermal energy when answering questions. For example, kinetic energy is converted to thermal energy. So let's move on to discuss the principle of conservation of energy, in short PCE. So what do you know about PCE?
I know, energy can never be created or destroyed.
Yes, that is correct. The principle of conservation of energy states, energy is never created or destroyed, but it can be transferred from one form to another. And the total energy of an isolated system is always constant. So the sum of initial energy is always equals to the sum of final energy. So let me give you some illustrations of PCE. For example A, you have a body falling through a viscous fluid, as we have discussed in topic 4. All the GPE will be converted to KE and thermal energy if the body is not at terminal speed. However, when the body is at terminal speed, all the GPE will only be converted to thermal energy.
Teacher, at terminal speed, why is the GPE converted to only thermal energy? What happened to the kinetic energy since the object is still moving?
That is a good question. Since the body is falling at constant speed, there is no further gain in KE. So all the GPE loss at that moment is converted to thermal energy only.
Oh, okay, I understand now. Thank you.
So for the next example B, we have a burning of fuel, such as the oil, coal or wood, and all the chemical energy will finally be converted to light and thermal energy. So the next example C is on a ball rolling on a horizontal surface comes to a stop. So in this case, all the kinetic energy will be converted to thermal energy finally. So in this case, it is the work done against friction. And for example D, there will be an alpha particle which is approaching a stationary nucleus, and the Ke at the start will be equals to the elastic potential energy at distance of closest approach. Alright, and we'll be discussing this on topic 20 on nuclear physics. So, any questions?
Teacher, can I ask you a general question? If we say that energy is always conserved, why do we worry about the world energy resources becoming depleted?
Oh, this is another good question. So, in the real world, a lot of useful energy ends up as the thermal energy of the environment. So, this energy cannot be easily converted back to useful energy, and it is not economical as well.
Thank you, now I understand.
Okay, so our next activity is to use a simulation on energy skate park to appreciate PCE. And the link is as listed on the screen, and you are supposed to access to the web link and complete the worksheet that I have given to you. And at the end of the activity, hand in your worksheet to me.